Good afternoon, everyone. Welcome to the JuiceFS office hour. My name is King, your host. So in last session, we covered the basic JuiceFS CSI driver for Kubernetes. Installation, create a secret, and create a static persistent value. So in today's session, we thrilled to have our senior support engineering, Ifu, to talk about some advanced CSI topic, including dynamic provisioning, how to configure the top options, and other advanced topics. So without further ado, let's welcome Ifu to the stage. Ifu, it's all yours.
Yeah, sure. Thank you, host. So the last time we ended at static provisioning. Okay, this is the most like fundamental or simple way to use a JuiceFS volume inside Kubernetes, right? You have a JuiceFS directory and you have some data already in place and you want to use it in pod. So you just create a static PV, persistent volume, and then the associating PVC resource here, and then you just mount it to the pod. Okay, plain and simple. But the problem is that the directory is shared across this entire PV. Okay, so all the pods that's using this PVC, they will eventually read and write to the same JuiceFS directory. This might not be the best thing when you have a lot of pods that's accessing separate data, and you want isolation between their storages. So the way to do that is to use dynamic provisioning. Okay, this is pretty much the same as standard Kubernetes dynamic provisioning. Okay, first of all, you need a storage class. Okay, so you need to create a storage class in advance. A storage class performs more or less like a template for bootstrapping persistent volumes. Okay, so you define the secret that is going to reference in the eventual PV, and then namespace. Okay, the most important bits here, I think, is the reclaim policy. Okay, do not forget this line because a lot of customers they forgot to set the retain policy. So by default, Kubernetes uses delete as the default reclaim policy. So when the PVC is deleted, the associating PV and the underlying JuiceFS data is also deleted from the system, which could be very dangerous if you don't have trash enabled. Okay, so when the trash is not enabled, the data just is lost. Okay, that's not very good. So do not forget reclaim policy, and that's most of the storage class notes to take. Before our historical version, I remember it was 0.24. You can actually define mount options inside storage class. Okay, but since we have ConfigMap to do that in newer versions of JuiceFS CSI Driver, this is not a good place to put more configurations in. So we recommend that you keep the storage class definition relatively simple, as shown in this code snippet here, and do not put mount options or any other configurations in the storage class itself, because there's better place to do that, and you don't want to scatter configurations here and there. Okay, makes it difficult to manage. Now that we have the storage class in place, we're going to create the persistent volume. The persistent volume claim, the PVC, because the PV is going to be created automatically by the storage class definition. Okay, so in this PVC, you do not need to select the specific persistent volume by selector, by label. You just define the associating storage class name, and it's going to reference the storage class that we created earlier. And then the PV is going to be initiated automatically. All right, so just a quick demonstration here. Okay, so I have the storage class already created here. Okay, so the persistent volume is not needed anymore. I just need the PVC and the application pod. And in the application pod, what I do is just a simple loop that echoes the timestamp and then write to a JuiceFS file. Okay, and I'm going to show you the current status on our CSI dashboard. Okay, so now the application is already started. I'm going to delete it first. And the moment the resources are deleted, it is quickly reflected in our dashboard. It is a pretty good product, and I recommend that all CSI Driver users should deploy CSI dashboard. It is very helpful. Okay, it is already deleted, so I can install it once again. The pod starts. Let's see. Okay, it is running now. Well, the creation is pretty simple, but once the application pod starts, the PV is created under a random UUID. Let me see if I can yes, after the resources are created, a new PV is created under a random string here. Okay, so each time a new pod starts that reference this PVC, a new PV is created. Okay, so you have isolation between storages inside each pod. Okay, and after this, we're going to go through the basic configurations. Okay, just navigate to the configurations chapter in our official CSI documentation. I'm going to briefly sort of browse through this this code snippet here. It shows all the things that our CSI driver is capable of configuring, okay? And what kind of PVC selector is supported. I'm not going to read it word by word, just go through the most important bits and the one that's more commonly used. Okay. So first of all, we have several different form of PVC selection. You can use a storage class name to select all the PVs that's been using a particular storage class. Okay, so that's very helpful for dynamic provisioning users, since you don't have to like manually modifying the persistent volumes that's already initiated. Okay, because when using storage class, if you add options, if you add other configurations to the storage class, it's not going to affect PV that's already created. Okay, it's only going to affect PV that's created later. Okay, only newer PVs are affected. This is not great in a lot of conditions, so we recommend that you use this PVC selector inside the config map in order to put config globally in that storage class. Next, we can of course select a particular PVC using its name. Okay, this saves the trouble of putting putting mount options or other resource definitions inside PVC annotation or inside the PV. Okay, so all the configurations are put together in this config map. Okay, you don't have to worry about other configurations scattered in other pieces of resources. And at last, if you want a configuration to be applied globally, you can just omit the PVC selector so that anything you write will be effective in all the PVCs. Okay, so mount options. Okay, you can define JuiceFS mount options inside inside this mount pod patch item here. And for example, this piece of configuration applies only to PVs that's using the JuiceFS minus SC storage class. Okay. And after mount options, we have host network. Host network is most helpful when you have limited amounts of IPs that can be assigned to pods in a Kubernetes environment. Yeah, because some Kubernetes distributors they apply sort of capacity limits to the nodes. So and you can only create a specific number of pods that has its own assigned IP in the environment. If you want to save like a couple of IPs in the Kubernetes worker node, you can enable host network for the mount pods. So the mount pods would just start using the host network namespace, so it doesn't take up a couple of IPs. And you can add you can customize labels to the selected PVCs and hence mount pods. The mount pod resource definition is also supported in the resources section. Usually, we recommend that you set a higher memory limit and also CPU limits for the mount pod, because we really don't want to like throttle the mount pod, and we don't want it to be like OM killed by memory limit that's too small. Okay, this will be introduced more detailedly in the next topic today. Okay, and as for the readiness probe and liveness probe, the thing here is that we don't really support liveness probe as of now, because it can be dangerous for the file system service. A mount pod doesn't need to be automatically restarted because the JuiceFS process has a watchdog, like a daemon service, and it protects the actual worker process. And if it fails at some point, it can restart the worker process from the daemon. Okay, it doesn't need a external liveness probe to restart the whole thing. Okay, so we do not recommend that you set liveness probe for our mount pod. Okay, this is in the example code snippet as a warning. But in contrast, you can use readiness probe. Okay, this is recommended, and you can use pod state monitoring to like monitor the status of the mount pod. Okay, that's pretty much it, and I'm going to show you how to configure all of this inside the CSI dashboard. Okay, the dashboard itself has matured in the year of 2025, but not to the level of perfection yet. So we're eager to hear more from our users and get more feedback on the CSI dashboard user experience, so we know how to improve it further. But right now, to edit the config map, you can just navigate to the settings page and then hit the edit button, because a lot of our customers are not really familiar with the YAML format of this mount pod patch field. So using the dashboard, there's a UI for this, and it's much easier to configure things in this way. So right now I have two pieces of configuration here, and just for demonstration's sake, I'm going to change the buffer size to 500 megabytes. Right? I'm going to save this config map, and it's going to present a line diff in the window. I'm going to click save here, and then in order for it to take effect, I can click apply so that the mount pods are upgraded smoothly without downtime. Okay, I can verify this using the logs in my application pod. So right now it's spitting timestamps and it's writing directly to a file under the JuiceFS PV. Okay, so when I hit apply and initiate the smooth upgrade process, I expect the data flow to hang for a short while, but no failures there. Okay, because the command is a simple bash loop with a pipe operator, and then teed to a file. If any write requests, if any of the write requests fail, my application pod is going to exit. It's going to crash. Okay, I do not expect it to crash. And let's verify that by hitting the apply button. It's going to create a job that roll out the mount pods. And then you can see my application pod hangs. Okay, so the fuse write requests is stuck for a short while, and then after the new mount pod is created, the application just continues as is shown here. Okay, this is a very good feature provided by our dashboard, and I encourage all CSI users to deploy and start using it today. So the last topic here is a optimizing performance. Well, performance tuning is not strictly related to the CSI driver. More of a general topic on the usage of JuiceFS. Well, I guess the only part that's related to CSI driver is that you have to set the resources definition smartly. Okay, use a memory requests that's large enough, but not to the point of waste. We have a recommendation that you should set this value to buffer size times 4. Okay, because in very intensive load scenarios, a lot of our customers, the resources usage are roughly 4 times the buffer size. Okay, this is no guarantee, just a recommendation that you can follow in when setting the initial resources definitions, and you should adjust it later according to the memory metrics. And then another important bits to follow here is to I recommend you to read the FIO benchmark section in our cloud service edition documentation. In the mount parameters pre-optimization section here, as many of our users may know already, the most important configuration that affects overall performance is the buffer size. The buffer size doesn't only control the length of read-write buffer inside the JuiceFS process. Okay, it also controls the concurrency level. The larger our buffer is, the more concurrency. So if you use the default buffer size, which is 300 megabytes, then when you do large file concurrent I/O, the performance will be throttled because there couldn't be enough concurrency. If your main like targeted scenario is big file, and you want to deal with multiple big files in parallel, I think you should start with buffer size of 1 or 2 gigs, right? That's 1024 or 2048. So on top of that, the upload and download concurrency is also controlled by the max uploads and max downloads parameters. Usually, our users do not need to tune this further because the default value is enough for like most of the cases. But if you're using an object storage system that yields high latency, in our experience, there's Google Cloud Project. Yeah, the GCP object storage usually has a bit higher latencies, from 100 milliseconds to like 4 to or 500 milliseconds. Okay, this is quite high. So when you're using GCP or R2 or other object storage services that has similar that has similar latencies, then you can increase max uploads and max downloads, like by 20% or something like that. Do not set a too exaggerated value because it might flood the system. Okay, so that's the most basic aspects of performance tuning inside JuiceFS. So and after these parameters are set, you wanted to verify if the performance actually increases. And then the thing is to go to the file systems page, then check the performance metrics. Okay, we have latencies metrics across all the aspects of our software. Okay, we have fuse operation latency, and metadata latency, and object storage latencies. And you wanted to see which one is the slowest, which one is causing you the most time. But the metrics script interval is by default 30 seconds. So it might not be enough, because your application may run very quickly and exit before any useful metrics are captured. And if this happens, we can collect JuiceFS stats inside the mount pod. Okay. So I'm going to find my my mount pod here in the system pod list. Then copy the mount pod name here. Okay, I can use the ps command to find out the actual mount point. And then use the JuiceFS stats command to output real-time performance data. Okay, so there's quite a lot of columns here. I'm going to reduce the verbose level. Okay, from here we can see all the latencies in each part of the data flow. There's object traffic and remote cache, well, which is the distributed cache, and block cache stands for local cache. I mean, the cache data that's written to your local cache directory. And we have metadata latencies here. Fuse, and this stands for fuse request latencies and read and write traffic. Okay, you can use this as a guideline to see if you have enough buffer size or concurrency level. Okay, and that's pretty much it. Just the basics of performance tuning with mount options. Okay, I'm going to wait here a bit to see if we have any questions.
No, thank you, Yifu. So this is a topic about how to customize our CSI driver with mount options using the dashboard and other tricks to observe the performance as well as to do some troubleshooting over there. So now we come to the Q&A session. So stay here for a couple, about like 10 minutes. Feel free to comment on the YouTube channel as well as the Slack channel. So we're happy to answer your questions. Okay, thanks everyone. So it's concluding today's session. Is forecast for the next session. We will continue our CSI journey to talk about the troubleshooting and also the optimization as well. So thank you for watching and see you again next time. Bye bye.
Goodbye.